All right, everybody. Good afternoon. My name is Juan Vivas. This is Will Cassie. We presented it last week. However, we did have to split up our presentation because of due to time. So I will continue on a presentation of calculus in sports, and I will just go ahead and go over real quick of what Will showed you guys, which is the first part, which was basketball, and I am going to talk about soccer. So, as you all know, cell phones are allowed throughout this presentation due to our interactivity with the students. And then we showed a little bit of the history. We showed you the application. Now remember, he's not going to dance again, so don't worry. Remember these applications because this will come in later on in this presentation. So just remember that we are applying either Newton's laws or scalar and vector quantities. He showed the basketball. He did the little dance. He showed you a mathematical. We asked questions. Will it hit the target? Now my part is about soccer. And no, I'm not gonna dance either. But as we go ahead and talk about the soccer as a part of my presentation. The first thing I would like to talk to you guys about is the structure of the soccer ball. Now, if we could really go back in time with the soccer ball, the one of the first soccer balls, it was just complete leather. And they found the big problem with this is that whenever it would rain, the ball would get really, really heavy, and it would it would rot. Because of, they would store it in whatever in a place that didn't have a lot of atmosphere, and it would rot and it would get really heavy, and so the players found this really difficult to play with. So this came along, and then they started changing the material of the soccer ball, which became a different type of leather. The materials inside also started to change, and as you can see here. It has this type of structure, but before it would just be three lines together all around the ball, and then so it'll be like three lines across and then three lines going down. And then this became to be like the sort of original structure of the soccer ball. Now chemical engineers took the soccer ball and completely changed the way it was made, not only because of the leather it had, but also they found a way so that it could create less friction and so that the contact with the soccer players' shoes would actually make it better for the soccer players to go ahead and kick at it. So when we think of soccer, the first thing is the law of inertia. Now the law of inertia tends, that as an object, it's just it'll basically do whatever the object is doing at the moment. So if a soccer ball is just sitting on the ground, it's gonna sit on the ground until some type of force moves it. And this is when the soccer player's kick actually comes in place. So as you have your phones out, which law of Newton's laws is this law that I'm talking about?
Wow.
Is it the first, second, or third law?
I'm gonna reword it. That's mine.
I'll give you guys a couple of seconds to go ahead and get your votes in. Five people have voted so far.
It's not working.
Yours is not working?
It's fine.
There's a little delay of a second.
Alright, nice.
Keyword there or something.
Okay, well, I am just going ahead and tell you, did anybody vote for the first law?
Obviously.
That as well. It's gotta be more than one.
Who voted for the first law? As in the law of inertia, which is actually the first law. So Newton's first law, which is the law of inertia, was about the soccer ball on the ground and staying like that stationary until a soccer player actually comes and kicks the ball. Next slide, please. And then, okay, so now think about, you are all familiar with soccer, right? You know, you gotta take the ball and score it in the net to get a goal. Now think that you are 30 meters from the goal, and you have a free kick, and you have defenders in the, you know, between yourself and scoring. Now ask your question if you will actually score. What do you guys think? Would he score? Yes or no? So just go ahead and answer that as soon as you can.
Wait, they're 30 meters away? Is that what you're saying?
30 meters
Does
away.
that have velocity or?
So he's 30 meters away from the goal,
Uh-huh.
and he has a free kick. So if you guys think about how it is, you have the line, you have this box, you have the outer box, here's the goal, and he's standing about, let's say, right over here. And there are defenders in the way. So the question is, being that far out, will he actually score the goal? So it's a sort of yes or no type of question, or however creative way you would like to answer.
Both codes are the same.
What do you?
That's a great game, right?
769879 on both of them.
This was open response, so it should be yes or no. So you type in yes, or you type in no.
Can we type in something else?
Or you can type in
Oh, okay, I see. what
whichever.
you're saying.
But I would stick to the yes or no, Raquel.
And you have all the necessary skill.
Yes. Well,
Like,
you're in the World Cup right now playing.
And you're Lionel Messi
It's a
or
Kendo effect.
Yeah.
or
You guys are really clever.
That was surprisingly.
I
that
know
was
who
not
put the first. I don't want to mention name, but
me. Wait, we're still voting.
It was you, wasn't it?
not me. That's a student.
That one.
All right. So with your clever responses, most of you said that he will score, and this is actually correct. Yes, he will score the ball, but you guys need to know how difficult it is for him to score, and I am actually going to show you the video of his soccer goal.
Is that you? Oh.
See how difficult that is?
That's inertia.
Brazil.
Keep it going.
Buffering.
Oh, buffering.
Who's buffering?
Now, do you know who's the player? I always teach you throw a curveball.
Why is it playing Kendo time?
Now, it's funny to know that when they asked him if he knew the types of laws he had used in that kick, he actually said, what laws? He actually had no idea the types of physics that was involved in his soccer goal. And sort of here, it explains to you a little bit of how it is known as like the impossible goal. So like as I said, he was 35 meters outside, and then he actually, according to him, he had practiced it a lot during practice, and he basically kicked it pointing in a direction away from the goal, so he was basically pointing towards the audience, and he said that he knew that he had to spin it and kick it as hard as he can for it to curve, and due to gravity, that is why it actually came along this path and scored. And it's funny because one of the ball players that was behind the net actually ducked down thinking that the ball was going to hit him, and it ended up going inside the goal. Now Newton's second law, force equals mass times acceleration. We could actually calculate the acceleration of the ball by dividing the force over the mass of the ball. So technically he was actually doing this without actually knowing that he was doing this. Having the whole physics involved in it of his soccer ball. Now, when we talk about the spinning of the ball while in the air and headers and vectors, we have to mention the drag force. Drag force basically is that as the ball is going in one direction, the air is actually pushing it back. So that's why when you actually kick the ball, it's going to create a path, but then it's going to eventually come down because the air is pushing it back. Now, this is known as drag force, and the problem with drag force is that that's one of the big opponents of a soccer player actually making the soccer ball due to the drag force. If it was up to them, they could just kick it straight and it go eventually really, really fast without the goalie actually being able to stop it. But the drag force actually slows it down. However, there is something that could decrease the drag force a lot, which is known as the Magnus effect. Now, the Magnus effect, what it does is that it creates an area of high pressure and an area of low pressure, with the resultant pressure force being perpendicular to the direction of the ball. So what this basically does is that these high and low pressures are what decreases the drag force. So while the ball is rotating in the air, the wind, the air effect that's underneath it, picks it up with the same wind that's moving it back, and then in the high pressure it creates the same thing. So basically the ball is able to rotate really, really, really fast without and it does not take drag force. The drag force is still there. However, it does decrease it a lot in order for the ball to go in that perfect spin path. So what was one of the applications we talked about in our presentation? If you could please answer. If anybody could remember, sit at the beginning of the presentation. And it's an open response type of thing. So what were two of the applications we mentioned in our presentation? I'll give you 15 seconds to go ahead and answer that. It was on a slide. Okay, well, I don't see any of the twos that we actually put up there, but one was Newton's laws, and the other one was scalar and vector quantities. I don't know if we have time to show you a video conclusion of our. So we're just gonna head and show you. This basically concludes all of our presentation, not only in basketball and soccer, but it'll show you other types of sports where our applications are being applied to. I don't know if Airwave is gonna be nice today.
I think we'll need to dance.
Sorry,
Dance
guys.
intermission.
Sorry.
Well, maybe not.
Yeah, no. Let's just go ahead and record on it. So next slide. And